Integration, page 14. So here they're asking us to do some complicated integrals, which are actually functions that came about due to the derivative chain rule. And they actually give you a hint on how you're supposed to do u substitutions for the chain rule. So, like for example, for this one, you see that there is a something, which happens to be this something, to the fourth. Disregard this for right now. Now, looks like a power, so the integral of x something to the fourth would be something to the fifth over 5, right? So let's test that. We're going to say, okay, what if our integral is going to be x cubed plus 1 to the fifth divided by 5 using the power rule? Now, I'm not worried about the chain rule yet. Let's take the derivative of that and see what we get. We're going to get 5x cubed plus 1 to the fourth divided by 5. The 5 cancels out. Remember that we have the chain rule, so we're going to get 3x squared. Okay, and wait, look at that. Look at the original function. We have 3x squared, and we have x cubed plus 1 to the fourth, x cubed plus 1 to the fourth. So their hint really helped us to figure out what the integral would be, which is this. Okay, let's look at the next one, see if it's that easy. So here, they're giving us a hint. The u substitution is going to be sine of x. So if that's the u substitution, that looks like u to the fourth. The integral of u to the fourth would be u to the fifth over 5. So that would look something like sine to the fifth of x divided by 5. And let's see if that is indeed the integral. Oh, by the way, I forgot to do plus c here, didn't I? Okay. So the let's test to see if this is the integral. Oh, I'm sorry, it's not the plus c there. The plus c goes here, right? Sorry about that. So, like for example, the plus c would go here also. Plus c. Okay, now let's try to take the derivative and see if it works. So the derivative of this would be 5 times sine of x to the fourth divided by 5, and then the chain rule of sine x would be cosine of x, and then the c would just disappear. Now let's see if that matches the original. So we have cosine of x, we have sine of x to the fourth, sine of x to the fourth, and then the 5 over 5 just disappears. So that also worked out. So yeah, that's exactly right. Okay. Now they're not giving us the u, but you can kind of tell what the u is going to be. Like, do you see that it looks like a big power rule here? Just ignore this for now. So let's say that u is equal to 2 plus x to the fourth. So then what we see here looks like u to the third, right? So the integral of u to the third would be u to the fourth over 4. So let's try that out. So it would be 2 plus x to the fourth, right? 2 plus x to the fourth divided by 4. Now let's test it out. We're going to take and then we need to put plus c, of course. Plus c. Okay. So let's take the derivative of that and see if it is really the integral. So we're going to take 4 times 2 plus x to the fourth to the third divided by 4. And then we do the chain rule, which would be 4x cubed. And then the c just disappears. The 4's cancel out. 2 plus x to the fourth to the third. 2 plus x to the fourth to the third. And the chain rule yields 4x to the third, so it worked. So the answer is this here, right? All right. What about this one? So this one, u looks like it would be like 1 minus x squared, just because that's in the inside part of the power rule. Let's rewrite this as something that we could take the power rule easily. It would look kind of like this, okay? And then so if this is the original function, the integral of that, we would take we would make the negative 5 one power higher, so it would be negative 4th, and then we would divide by negative 4th, and then disregard the x for now, and then we'll say that, okay, that's the integral, and then we're going to test it out. We're going to take the integral, so negative 4 1 minus x squared to the negative 5th, and then we have negative 4 on the bottom too, and then the chain rule gives us negative 2x. Negative 2x. Is that right? Negative 2x. Yeah, it does. So did that work out? Almost, right? The negative 4's cancel out. 1 minus x squared. The x matches too. Do you see this x? This x matches with this x. The only problem is we got this negative 2 left over. So we do need to put an additional negative 2 in the denominator so that we would cancel out this negative 2. Now it works out, right? Now it looks exactly like the original function. So just to simplify, let's simplify this. We'll put, so the negative 4 and the negative 2 multiplied times each other, and the denominator would be 1/8. And if we wanted to, we could put the numerator here in the denominator, 1 minus x squared to the 4th plus c. Okay? So that was slightly more complex, so you had to make an adjustment there. 3. So we have this messy looking thing. The u substitution is probably going to be this, so we're actually taking, we're going to take the derivative of, or the integral of e to the u, which would just be e to the u. So let's try that and see. So let's say that the integral is e to the 1 minus 2x itself plus c. And then let's test it by taking the derivative. We're going to get e to the 1 minus 2x, and then we multiply times the chain rule, negative 2. The plus c just disappears, right? And let's compare that to what we originally have. So the negative 2, and the rest also matches. So it's perfect, yeah. So our answer is, our integral is that. Okay, next one. So now we have this messy looking thing. So we have, let's say that the u is square root of x. So u is equal to square root of x. So that's, we're just going to take the derivative, or the integral of e to the u. So the function would be e to the u itself, e to the square root of x. And so now let's take the derivative of it, see how close we are. The derivative of e to the square root of x would be e to the square root of x, and then the chain rule, the derivative of square root of x would be 1/2 x to the negative 1/2. And so let's check that out. Simplify it. So I'm going to rewrite it. It's going to be 1/2 e to the square root of x, but in the denominator we're going to have square root of x. And that looks a lot like what we have here. That matches, and this matches. The only thing that doesn't match is the 1/2. How do we get rid of the half? What if we multiplied the initial function by 2? Then when the half comes out of the, now why did the half come out again? Ah, yes, no. Oh yeah, because the derivative of square root of x is 1/2 x to the negative 1/2. Okay, so yeah, so if we put a 2 here, then the 2 would be here, and then when the half came out, they would cancel. So yeah, we want the 2 to be there. Okay, now I think it's okay. All right, number 4. So let's assume that that's the u. So 1 over u, the integral of that would be log of u, right? So let's try that. Log of x squared plus 1. Now let's, and plus c, of course. Now let's take the derivative of that and see what we get. So we'll get 1 over x squared plus 1. Chain rule of x squared plus 1 would be 2x. We'll put that in the numerator. The derivative of c, of course, is nothing. And then it looks like it matches perfectly, doesn't it? 2x, 2x. X squared plus 1, x squared plus 1. So we guessed perfectly right. All right, next one. So in this one, might be a little confusing. It looks like you've got a rational function here, stuff on the top, stuff on the bottom. The higher order term is on the bottom. So let's assume that the higher order bottom is the u. So let's say that's 1 over u. The integral of 1 over u would be log of u again. So let's assume that it's going to be log of x squared minus 3x. X squared minus 3x. And if we take the derivative of that, it'd be 1 over x squared minus 3x. And then we'll take the chain rule, and that would give us 2x. Okay, oh, don't forget the plus c, of course. Now let's see if it matches. Oh, it would be 2x minus 3, right? 2x minus 3 using the chain rule. And then let's check to see if it matches the original function. 2x minus 3, 2x minus 3. X squared minus 3x, x squared minus 3, it matches. So our function would be this. Alright, almost to the end now. Integrate by substitution. The more complicated looking part of it is this. So let's assume that this is the u. Looks like it would be like 1 over square root of u, something like that. So the integral of 1 over the square root of u, well, let's rewrite it first. We can rewrite that as u to the negative 1/2. So the integral of that would be u, and then we'll raise it by 1 power, and then we'll multiply by the inverse, so 2u to the 1/2. That would be our guess. So let's try that. We're going to say 2 cosine x to the 1/2. And then we're going to take the derivative of that, see if it works. Oops, don't forget plus c. So let's take the derivative of that, see if it works. The derivative of that would be 2 times 1/2 times cosine of x to the negative 1/2. And then we have to take the chain rule. What's inside it would be negative sine of x. Now the 2's cancel out there. And then we end up with negative sine of x times the cosine of x to the negative 1/2. Looks like we have some things matching up here. Sine of x matches up with sine of x. The cosine to the negative 1/2 power also matches up. The only thing that doesn't match up is the negative sign. So in order to compensate for the negative sign, we could put a negative here, and then the negative would be here, and it would cancel out with the negative that comes out of the chain rule. So the negative and the negative cancels out, and then we would end up with a positive here. So we just add a negative there, and then now it's perfect. Alright, last one. So again, the more complicated part of the function looks like that. So we'll assume that that is the u. So we're going to have square root of the integral of square root of u would, and then we could rewrite that, of course, as square root of u is u to the 1/2. So the integral of that would be u to the 3/2 times 2/3. So let's try that out. We're going to try out 2/3 times the sine of x to the 3/2, and then plus c. And then to test that out, we're going to take the derivative of it. So we'll have 2/3 times 3/2, those are going to cancel out, times the sine of x to the 1/2. And then we'll take the chain rule. It's going to be cosine of x, and then the plus c just disappears, right? Let's see. And then, so these cancel out. We get 1. So we have sine of x square root times the cosine of x. And yeah, that worked out, right? This is that. And this is that. So it's perfect. The answer then would be this function. We didn't need to make any modifications. Okay, and that's it.